Good morning. Morning, everybody. Good morning, everybody. So, welcome to my class again. CSE 1321 Programming and Problem Solving 1. So, before I start, I want to apologize because my last lecture was not recorded correctly due to system error. I will upload the video maybe, but sound was not recorded. So, I want to go quick our last lecture, introduction lecture today. Then we will start our first lecture with module 1. So I want everybody to follow the schedule posted on the first year experience page, and the schedule is here on the top. Okay, so if you go to the schedule, okay, so our theory schedule is different than the lab schedule. I'm getting some email about some information about lab assignments, lab work. Okay, I am not teaching any lab course in this semester. So for your any information regarding your lab assignment submission, okay, so please email to your corresponding lab instructor. Okay, I am only for this theory or lecture class, and in this theory or lecture class we will cover most of the time, sometime we will use algorithm or pseudocode, algorithm in pseudocode. Sometime we will use live program to demonstrate some concept. Okay. You will practice in depth. So everybody should or must need to assign a corresponding 1 credit hour lab course. Is everybody here? Or anybody here that has not assigned a lab course yet? It's good. Everybody got it, okay? Syllabus, if you see the schedule, there is a syllabus quiz. It is called syllabus or policy quiz that is due on this weekend. So all quizzes are due on Sundays before midnight. So please do not wait until the last hour. Originally it was on Friday, but we extended 2 more days to give you some relax. You can take it on Saturday or Saturday night or any time or Sunday, okay? But please do not wait until last hour. And if you miss a quiz, it is difficult for me to give you an extension. There are other sections, and this program goes under a team. Surveillance under a team, surveillance, okay? So they observe to whom I am giving extra ordinary some extension or something, okay? I don't like to be caught, and I don't like you to be caught. Okay, so please follow the instruction, and before this deadline you can take the quizzes anytime. Most of the quizzes have at least 1 hour or some 2 hours time duration, but you should not take that much time. But before you take the quiz, study please first. Okay. As I mentioned, then I want to go quickly about our introduction. Slide again. Again, I would like to welcome you to our first year experience program, CSE 1321 Programming and Problem Solving. As we discussed that you are here to get one of your majors in computer science, software engineering, in or IT, right? So this course will be your entrance or gateway to that path. There is another course actually, 1322, that for that this course is the prerequisite. So in this course, what you will be learning, how to solve a problem, maybe a real life problem or an imaginary problem or a future problem using a computer program. Okay, but we will go through systematical way from bottom to up. We'll discuss what do I mean by systematic way in a few minutes. Okay, so I covered this in our first class, but sorry, voice was not recorded. One of the things that I would like to mention, 9th is the due date to withdraw without any academic penalty, but I do not wish any of my students will withdraw from my course. I will try my best to keep. Okay, and in our first lecture, mainly we discuss policies, rules, and guidelines. Okay, so beyond these guidelines, maybe I have my personal restriction that I want to implement that I did not tell you in our last lecture, but I want to tell you today, and I want to implement that from our next class. My restriction is that, as I told you, that I will be recording my lecture. So my lecture videos will be posted on my YouTube channel, that for free. Almost all of the resources will be available online. If I do a live program, I will post the program on GitHub. From your next week, we will be familiar with GitHub, okay? Don't worry. So you do not need to type in or to keep record everything line by line for my class. I like you to rather give more focus what I discuss. You know, I have a limitation. You know, my English accent is something weird, right? I'm not an American native English speaker. My actually in English is British accent. Okay. So if you please give attention to me, to my body language, it will be easy for you to understand. Okay. So this is why I want to implement that. Since you do not need to use computer or any electronic device to record, so unless it is needed for you to really to use computer to keep your record, I like to forbid everybody not to open any computer or any electronic device, especially mobiles or tablet, during my class hour. But if you need that, please come and sit in the front few benches, okay? My goal is to ensure that you are giving focus to my lecture, not anything else. Previously, we have noticed that some students, they sit in the anywhere back and they do social working, networking, texting, listening something else, or watching movie. So I want to ensure that you will not do that. Okay, I want you to focus. That is important right now. If you have something important, if you get a phone call, emergency something, please go silently out of this room and then receive the phone, come back silent. Okay, but do not do any texting from while living here. But doing single thing, one thing is minor thing is okay. But do not spend too much time focusing. My goal is that to give you 100% attention here. If you lose your attention for a few minutes today, another few minutes tomorrow, maybe next week, you will not be able to understand something important. I like everybody to get an A in this course, B, at least B. Okay. So anyone has any alternative to my? If you have, please contact me personally or send me an email. Okay. That is not my for my personal interest, for your interest. I want to implement that. So if you really want to open your computer on it, sit in the front line from next class. Okay, that's all. And let us go to our. So because you see that we have 8 modules and we have only 16 weeks, right? And within this 16 week, we have 4 tests. So on the day of test day, at least 3 test days, we will not be able to teach learn something new. And rather than besides that, we will miss some classes due to holidays. Sometimes maybe I may be sick or out of town for conference or something. Okay, about 13 or 14 weeks, maybe 14 weeks. We have to cover everything. So in some weeks we have to cover more than 1 modules, and these are the foundation for your programming. Okay, so I will go through what do I mean by foundation shortly. So this is our module 1 or starting programming. So you know that the title of this course is Programming and Problem Solving. Okay. So I do not expect that all of you will have or should have some previous programming experience in order to be succeeded in this course, but I expect that you have a strong motivation, okay, an intention to learn something new. In order to learn something new, actually we need to go through a systematic way. That is, we need to think algorithmically. The term you see here, algorithmic thinking. Okay, we will discuss what is an algorithm today, and then what are the components and properties of algorithm. Anyone has idea about what is an algorithm? Can anyone volunteer? What is an algorithm? Yes. Thank you. Anyone else differently? An algorithm is a combination of some steps to solve a problem. Okay, that's good. Anyone else has something in mind? Steps, but I want to add something more. An algorithm is a step-by-step logical process. Your steps should be logical and process should be complete and not vague but abstract. We will discuss this. So my goal in this lecture to understand what is an algorithm, the concept of an algorithm, and another new thing, the concept of abstraction. Okay, I will go through this and then we will discuss maybe relation between programming, algorithm and programming, maybe to next class. So we got a definition of algorithm. An algorithm is actually, in other words, you can say it is a recipe. The recipe, that means when you want to cook something, you have a recipe. That means you have some ingredients, maybe some vegetables or rice, you have some instructions. In order to cook something, you need to have some ingredients and some instructions, and you have to follow the instruction step by step and sequentially. For instance, if you want to cook a chocolate or something, there are some instructions over here. You need to follow this instruction mostly step by step. And there might have some instructions. If you miss that instruction, maybe you will not get your expected output. For instance, think about while cooking, if you do not turn on your oven, right? Whatever else you do, you will not get expected output, right? So we have to follow, sometime we have to follow the instruction step by step, and instruction should be completed, and this should be consistent and logical. So we are coming back here. So an algorithm has mainly two ingredients: data and instructions. For cooking stuffs, for cooking something, maybe your data will be some vegetables or rice, and the instruction will be when to put oil, when to put sugar, onion, and the other stuffs, right? So in your algorithm, your instructions must be logical and systematic and follow the directions. So every day in our daily life, you use algorithm by knowing or unknowingly. We follow, always do some steps. For instance, think about situation when you registered in this course. You followed some step, right? You went to your Owl Express and then select the course number, and then you click some button, and then you got registered, right? Those are the steps. For instance, if I ask you to very simple thing to do an arithmetic operation. For instance, 2 plus 3 times 5. Okay, 2 plus 3 times 5. Let me make it simple. 2 plus 3 times 5. So as we are familiar with this arithmetic expression, right? Our result will be 17. Okay, but so that why it is 17? Because we followed the arithmetic operations rule that instead of using the plus operator first, we use the multiplication operator first, right? So we got 15 plus 2, 17. I did not follow the arithmetic rule, then I would get a different result, right? 3 plus 5, no, 2 plus 3, 5, 5 times 5, 25. That is a wrong result. Okay, so here, what are our data here? Our data are 2, 3, and 5, these numerical numbers. And what are our instructions here? Plus sign and multiplication sign, right? So when we use our instructions properly on this data set, we will get our expected result, right? So concept of an algorithm is that you will have some data and some instructions that will be applied on your data, then you will get your result. So visually an algorithm is like this. You will have some input, the data, and then you will put algorithm, that means instructions here. Okay, apply your algorithm here, and then you will get your expected output. But as you know that we have to follow the instructions, okay, systematic way, otherwise we will not get expected result, or sometimes it will be difficult for us to solve a problem. For instance, let me give you an example. Okay, if I have money, okay, and if I ask my little son, he's in school going, elementary school going boy, if I show him a house, good house in this town, and tell him, okay, this is my money, okay, use my money, and we want to build a house like this, okay, a fancy house like this. Go to your store, even online or Home Depot or buy or give order whatever you need. Okay? Giving money to my son and asking him to solve a problem. To, like, my problem is build a house. The goal is to build a house like this. A good house, okay? Think about situation. What is likely that my son will select? Maybe he will select the fancy, or he will select the window, line, carpet, tiles, lighting first, right? You will select that because he sees the nice carpet, nice tiles, blinds, windows, door, furnitures, right? On the other hand, if I ask a constructor or a builder, and if I tell him, I have this money, and I want you to build a house like this, go Home Depot or Amazon.com or anywhere and buy whatever you need. So what he will purchase first? What do you expect? Yes, he will buy some plumber, cement, rod, wood, or something. So there you see that problem is same, right? To build a house, he selected some other stuffs completely different than a builder or a constructor selected, right? So who is correct? Who is systematic? My son, the young son, or the builder? Builder, we know that, right? A builder knows that he will need these windows and then these stuffs all the way in, right? So he's not going to waste my money or waste my storage by purchasing those stuffs that will be needed all the way in. But since my son, he does not have enough knowledge how to solve this problem, from where to start, so he went to top. That is called top-down process. He started from top. Okay. While the builder started from down. Right? Okay, so our goal is to which approach you want to follow. Our goal is to solve problem like this, but which process we should follow? Top down, top to down, or down to up, bottom to up? Yes. So our goal is to follow a systematic way, algorithmically. That means whenever you find something to solve it, you got a problem, you have to think yourself first what is needed. That is the algorithm. Then second the algorithm in your head or mind. Then implement that algorithm. First writing first you can develop an algorithm, and then write code. So many people who want to learn programming, but they do not follow algorithmic way. They just start, sometimes they purchase a book, programming book, or start watching video. And at the beginning, they find it interesting, okay, but at the end, they do not learn. Our goal is to prepare you to go systematically, think algorithmically, so that you become efficient or skilled to solve your problem, right? So this is why we need to think algorithmically. And algorithmically, in other way, it is called critical thinking, or sometimes it's called abstract thinking. The word abstract here is a vague, is a concept. But in the field of programming, you will hear a lot of time that's called abstraction. Abstract. Okay. Abstraction means something, that's a concept that is not visible, that not is touchable. Okay. When I asked you to do the arithmetic operation 2 plus 3 times 5, so you thought that in abstract mind, you thought that, I know everybody knows that it's very simple. In order to do that, you thought abstractly, you thought algorithmically, you thought critically, right? That was why the multiplications first instead of the addition, right? If you did not think that way, algorithmically or critically, then you would not be able to get that great result. So what are our abstraction over here on this simple word, simple expression 2 plus 3 times 5? We know the plus sign, multiplication sign, okay? Okay, we know that plus signs mean add two numbers, okay? And then we are familiar with those concepts from our beginning. Of course, we will use most of our pre-acid knowledge or mathematical operation. About 90% of time you will use your previous knowledge. Only a few times we will use something new that you are not expected to know. We will use those knowledge systematically, and we will implement those abstractly. So but abstraction means, okay, the concept plus sign. So it has its own logical concept, plus sign or multiplication sign. For instance, if I would tell you, okay, do the operation 2 plus 3 times Mokhtar Hussain, my name, would you be able to solve this problem? 2 plus 3 times my name, Mokhtar Hussain, right? We know that it is not meaningful, right? Because the multiplication operator needs two numerical numbers in both sides, right? That will not work. Okay. So instead, so sometimes the abstraction is a concept that hides something in order to focus something else that is more important. In our last lecture, I gave you an example how to drive from here to downtown or Kennesaw campus. Okay, so if I want to drive from here to Kennesaw campus, what do we do? Can you sit over here, please? So what do we do? So we do Google search. We do direction. We get a direction from our Google, right? From our map. So usually it says go 2 miles straight, then turn right, then go 500 feet or something, then turn left or something, right? But it does not tell you or it does not tell me that go 2 miles and then stop, right? And go turn right, then yield, or then or stop and then turn left, because the the stop and the stop sign or some emergencies obstruct are hidden, or these are told implicitly, right? There might have some problem if my Google map say that go 2 miles and then stop, then I would get it, maybe travel, then I would stop here around certain time, right? Because I saw if I follow the Google map and say stop over here, and if I follow stop, it does not say me stop how long. That might be a problem. So sometime in order to implement our algorithm, sometime we will use some abstract concept. For instance, okay, print something. I think everybody is familiar with how to print something using a printer and computer, right? So when you just give a print command, if your printer is set up well, then it will be printing, right? So in order to print something, you do not need to know exactly how the computer sends your data to the printer and how printer prints it. Similarly, in order to drive a car, in order to drive a vehicle, we need to start the vehicle first, right? But how we do not need to know how the ignition system works, how the engine starts and how it works. Do we need to know that in order to be a good driver? No, if you know that, that will be beneficial. But a mechanical engineer needs to know that, right? If he wants to build or fix that car. Okay. So here, when I'm driving, we are relaxed to focus on our front and surrounding places, left or right or back, instead of giving focus how the engine is moving or ignition system is working. Think about the situation. If you would have to focus every minute or every second or after every hour, how the engine is working, is my engine working, is the light working, then would we be able to give more focus on driving? No, because the engine ignition system is abstract over here. So that means we are not focusing on that. We are focusing on something else, how to drive, right? So that is the concept of abstraction. The ignition system is abstract to us, hidden to us. We focus on that, okay? So that we can give something, focus on something else. So before I come to here on this page, I want to go back to this page. So these are the properties of an algorithm. A good algorithm should be precise, and it should be unambiguous, and it needs to be complete, it should be correct, it should be simple, and it should have some level of abstraction. So I know that except the last point, everybody should be familiar with the other 5 properties, right? Except the last one. But meanwhile, we got some idea about abstraction. I will give more focus on this. Okay, so an algorithm must be precise, unambiguous, complete, correct, and simple as possible. Now, if I come back to this algorithm, can you please help me to see what is the wrong of this algorithm? Do you see anything wrong in this algorithm? Okay, what are the, tell me one by one. Yes, okay. It's not precise or it's not complete, right? Okay, it does not say how long I have to repeat. how long I have to rinse, right? Anyone else? Any issue? Okay, that's another point. And anyone else? Yes. Yes. It does not tell you what the quantity of what is meant by small, right? Okay. And anything else? Yes. Huh? When to? Yes, that is incomplete. Yes. Okay, so we may find a number of issues in this algorithm, right? In this version. Okay. So now we understand that an algorithm needs to be complete, it needs to be correct, and it needs to be precise and logical, right? Okay. And another thing is that there are some abstract. Tell one of the abstract thing here. Something abstraction here. Yes. Yes. Anything else? Yes. Yes, there is. Yes. How to rinse? It does not tell you how to rinse, right? Okay. And it does not tell you how to wait here. It does not tell warm water or cool water, or what is that called? Hot water, right? It depends on situation. If you are so there are some abstract concept over here, right? So by either knowing or unknowingly, we are using some abstraction. There are some level of abstraction in this algorithm, right? So you got some idea what are the abstract thing. For instance, how to rinse, right? It does not tell you. Similarly, for instance, if I tell you, please turn on or turn off the light, right? So just if I ask you to turn on the light, I'm supposed to tell you just this, request this. I should not tell you go there and look at the switch and click on the button. Okay, those are the steps, those are hidden abstract. So you got some idea about some abstract things. In computer programming, you will hear this abstract word a lot of times. Concept is not visible. Okay, it is not visible, it is just a concept. But we will use that while implementing our algorithm precisely. For instance, if I would not use any abstraction level over here, then I have to tell here how to wait here, right? Use hot water or warm water, turn on the what is that called? Bathtub switch, something, a lot of things. So in order to solve this problem, you can write your algorithm maybe 2 pages, 3 pages, right? 4 pages. You write a lot. So, but we want to make our algorithm size. How to make it precise? Using abstract concept. Okay? For instance, in our program, you will see that we use what? Only the method we will use print. But we will not tell. At this point, we will not be learning how actual computer program prints something. Later, you can learn that. So an algorithm, we know that an algorithm is a what? Step-by-step logical process, right? And an algorithm can be implemented in multiple ways. It can be described in natural language, in straight language, in English or any other language that you understand. Okay. It can be implemented by a flowchart. Okay. And it can be implemented by pseudocode, writing pseudocode, and then finally a specific programming language. Our goal is to implement an algorithm with a specific programming language, either C# or Python or C++ or Java. In our course, we will start describing an algorithm with pseudocode, with picture. Sometimes, most of the time, with pseudocode, but we will implement that in one of the programming languages, C++, C#, Python, or Java. Okay. So now we understand that what is an algorithm. Algorithm is a step-by-step process, description how to solve a problem, and how we can describe an algorithm in different ways. You can have a picture. Sometimes a picture, a single picture tells you 1,000 lines of statement, right? Sometimes we may have videos. Audio video, right? Here, the algorithm can be implemented by video. So we are not using video, but sometimes we will use flowchart, and then most of the time we will use pseudocode, and finally we will go to implement that algorithm using a specific programming language. Or sometimes we will use multiple programming languages to implement one algorithm to understand the differences between language to language. Okay, so the systematic way to solve a problem is to understand pseudocode. To write a pseudocode first. In order to write, while writing pseudocode, you will be thinking algorithmically, critically, with abstraction in your mind, and then finally we will be writing a program. This is the way to learn how to solve a problem. This is called bottom to up. Okay, like a constructor constructs a house, right? But that is not the appropriate way. When you get a problem and right away you will be starting writing a program. That is the thing that people who do not have academic degree or experience in computer science or programming or software engineering, they do that way. But we will go systematic way from bottom to. That will take some time. Okay, in order to do this in systematic way, that will take some time. Maybe, for instance, I gave you an example how to build a house. Okay, even if I call like a constructor and give him money, he will buy a lot of maybe things that will go underground or basement. My son may not be happy. He would think that, oh, these are the garbage thing. Why do we need that? I don't need that. I need this fancy blind or carpet or tiles, right? So from our next class, we will be starting. Okay. So, but this by the end of this week, so I like you to go through our first year experience page and these first two slides and have a look. We will start from here, wherever we stop here. And please do not forget for the policy and syllabus quizzes that are due this weekend. Okay, thank you so much. Have a good day.